Hi everyone, we're back. This is the second part of the video for the 10-1 Modeling and Writing Expressions worksheet. This is the back of the worksheet. If you're watching this video, I hope that you have solved the front side of the worksheet and checked your answers with the first video. And now you can use this video to check your answers or get some instruction on the second side of the worksheet. So let's get started. Number 1 reads, Jessica rode 9 miles farther than Roger rode. Let R represent the number of miles Roger rode. Write an expression for the number of miles Jessica rode. So if you're unclear about what this is asking, we're going to write an expression. And on the front, we practice what expressions were. So for example, expressions could be things like x minus 9, or 3 times y, or z divided by 13. Expressions are math problems where we don't have all the information. In this case, what we do know is we do know that she rode 9 miles farther than Roger rode, and we know Roger rode R miles. It says let R represent the number of miles Roger rode. So how would I figure out 9 miles farther than Roger? Well, I'd start with how far Roger rode, and then I would add 9 to it. Now, if you're wondering where I got the 9, it's just right here. If you're wondering where I got the farther, it's because I'm interpreting the word farther as we're going to need to add. Okay, let's check out number 2. Let M represent the number of children playing soccer. Those children are separated into 4 equal teams. When you see that word separated, I hope you think division. Write an expression for the number of children on each team. So a bunch of kids are playing soccer, and they are separated into 4 teams. Now that is the correct answer, but a better way to write that answer would be, and it's simply because as we move into algebra, we start writing division as a fraction. So that's the better. It's not wrong to write m. It's not wrong to write this one, m divided by 4. It's just better in algebra to write m over 4 using a fraction. Let's check out number 3. Glenda bought some apps for her tablet. Each app cost $5. Let n represent the number of apps she bought. Write an expression to show the total amount she spent. Again, we're writing a math problem where we know one of the numbers, 5, we don't know the other number, n, and we don't know the operation, so we need to figure it out. So let's pretend that you were getting ready to buy some apps for your device, and they were $5 each. And you bought one for, I don't even know what, let's pretend you had to pay for Google Classroom, and that was $5, and then Netflix, and that was $5, and then a game, and that was $5. Well, how much did you spend? You spent $15. That's because you did 5 times 3. Well, in this case, we just don't know how many apps she bought. It says she bought some apps. How many? We don't know. But we do know they're $5 each. So the fastest way to get that would be 5 times the number of apps she bought. It says right here, let n be the number of apps she bought. So this one is 5 times n. That's all we have to write is 5 times n. Please do not write 5 times in that way, because we don't know what that x is right there. Is that x a variable, or is it a multiplication sign? We don't do that. What we do simply is 5 right next to the variable, 5 times n. That's it. Okay, we're going to go pretty quickly through 4 through 11. It says write each phrase as a numerical or algebraic expression. When there are multiple answers, I'll probably write a couple, but I'm not going to write all of them. Number 4 says 25 multiplied by 3. Probably the most algebraic way to write this would be 25 either dot 3 or 25 times 3 using parentheses. We are not going to use the x. Number 5, 3 added to n. I kind of like to start with the n and then add 3 to it, but if you had it backwards and did n, if you did it the other way and did 3 plus n, it is okay. And the reason why The reason why it's okay is because we have this thing called the commutative property of addition that states that we can add in any order we feel like, so it doesn't matter which one goes first. I prefer the one on the left. Number 6, r divided by 8. The better one would be r over 8, or we could just write it in a linear fashion, r divided by 8. Number 7, the product of 7 and m. Product means to multiply, so we're just going to write 7m. We're not going to do anything else. We're not going to put an x or a dot, just 7m. Number 8, the difference between 48 and 13. We have to recognize that the word difference is subtraction. So we're going to do 48 minus 13. Number 9, the quotient of 18 and 3. I prefer 18 over 3 because that's the most algebraic answer. Or we could write 18 divided by 3 left to right. Number 10, 189 subtracted from t. This is the kind of subtraction problem that can trick kids, so be careful. What is being subtracted? 189. What is it being subtracted from t? It's t minus 189. Number 11, the sum of w and 253. As I mentioned earlier, we can write this in any order you want because of the commutative property of addition. Okay, let's check out the bottom of the page. Write 2 word phrases for each expression. There's going to be, this is one where answers will vary. Your answers might not look exactly like mine, but I'll just pick out a couple. T plus 23, you literally could write T plus 23. That to me is a little too simple. I prefer things like the sum of T and 23, semicolon. I'm going to do another one because it asked me to. It says write 2 word phrases. We could write 23, 23 added to T. Alright, let's move on. Number 13, subtraction 1. These are the tricky ones. We could do a very simple, just 45 minus n, or the difference between, which I'm going to do. The difference between 45 and n. And then my second one is going to be that tricky one. It's going to be the what is being subtracted from what. Well, 45 is the greater number. N is being subtracted from 45, so that's what I'm going to say. N subtracted from 45. And our last question. This is going to be an answer varies to. Solve. Number 14 reads, write an expression that has 2 terms. That just means 2 things, like a number and a letter. Your expression should have a variable and a constant. The variable is the letter, like x or y or n or something like that, and the constant is a number. And that is a really fancy way of saying write anything we did on this page. For example, we did w plus 253. That's in it. I need to write over here, answers vary. There are a million unlimited answers here. But anything we did on this page would count, as long as it has a variable and a constant. So we could do w plus 253, because that's one of the things we did on this page. Or we could do t minus 189. What do these two expressions have in common? Well, they both have a variable and a constant. A variable and a constant. I could do 3x, that has a variable and a constant. I could do 14 divided by y, that has a variable and a constant. There are unlimited answers here, and you just have to make one up. Okay, great job. Thanks for watching.